Okay, I'm gonna, it's 10 minutes, so I'm gonna go as quick as I can. As you can see, the title of my session is Rethinking Data, a data scientist's first dive into graph query languages. Also, I'm Suha Makala, sorry about the delay, and the data scientist in this talk is me. And this is the agenda for the talk today. I'm going to start by introducing myself and talk a little bit about the problem at hand, the data set that I am working with, SQL way, and how I was able to graph database and the process I followed there, how I did on a post data set, time permits, key takeaways that I to toward this journey. A little bit about I have a PhD in engineering from the University of Georgia. I graduated in 2023, and my dissertation is mainly focused on detection and recognition technologies in visible and thermal spectra using generative network for image synthesis. Currently, I'm a data scientist at an amazing media agency called Attention. As you can see, I started working there very recently, and the key projects I'm working on are attribution estimation for linear TV and anomaly detection and ad serving. The problem I tried to address here is anomaly detection in ad serving. So the problem here is um, usually clients spend a lot of money to serve ads, and if you're serving these ads to bots, then that is just money right down the drain. So the way to get this or figure this out is to detect anomalies. The assumption being here that routines, we work, play, sleep, and do other activities pretty much at the same time every day, or at least most of us. Bots do not. So this is an anomalies. So the first step we try to take detecting anomalies in the population are calculations disproportionate population, as in if a city has a population of 100,000 people, are we serving 1 million impressions instead? And just a disclaimer that I'm not going to talk about how I solved this problem, just how graph database using graph databases provided me a different and more intuitive way of looking at this data. The data sets I had access to were impressions in September and October of the year with timestamps, zip codes, cities, and states. And I also have access to census data, which is population broken down by zip code. And to break down the problem, the impression effectiveness varies by time of day of the week, because people are at work during the day and most of the people are sleeping at night. And there is a time period between work and sleep where people are just winding down, having fun, having dinner, or whatever. So the commuter population impacts these workday hour impressions. Nighttime impressions are affected by sleep patterns. Not people are actively using devices where ads are served. And 15%, it's assumed that 15% of the population awake from 11 p.m. to 6 a.m. That means the night population is population times 0.15 to get there. I know I'm talking a lot of math here, but don't worry about it. It will make sense at the end. If not, it's because we are still in that is the intuitive way to look at this data set is by using the database. So if it doesn't make any sense now, it's fine. But it's also assumed that everyone receives an impression during sleep hours as well as non-work hours. The work hours, which are assumed to be 7 a.m. to 7 p.m., is not included in this data set or this talk. Then for the non-work hours and sleep population, the estimated impressions are 1%. The assumption is that we serve one impression per device during the non-work hours and sleep hours, which makes the total number of impressions in a month. It's simply population multiplied by 30 or 30 a month, and the actual impressions were obtained by adding the impressions by month. And anomalies are where these actual impressions are greater than estimated impressions. As you can see, there is a lot of math going on here, a lot of tables. So as a result, it turned into a spaghetti tables quickly. Spaghetti I was talking about, there is a table, sleep time, population, actual impressions. There is another table with hourly impressions, and the table with census and population statistics. As an example here, there is this population and estimated sleep time impressions per month. And there is this another table where we have impressions by hour during a particular month on a day, for example, October 15th at hour 17 p.m. These are the impressions served. So while looking at multiple tables at once is one thing, but these tables cannot also be joined because of the entirely different set of constraints imposed on these tables. To address this is how I started my journey in Neo4j and Cypher by using Neo4j's Graph Academy, which is very straightforward to use. I just created an account super quick. It has clear examples and instructions to follow. And as you can see here, the Neo4j fundamentals, so the course, which took me less than 2 hours to finish, put those together. And here is an example interface where there are clear instructions. There is some syntax here. You can simply run this. As simple as that, you visualize your database, and also there are some functions just at the end of some of the modules, which helps you understand what you're doing and learn more. After doing this doing these two courses, I started using Neo4j Desktop version, which is simply Neo4j app or Neo4j Desktop application and login and start coding. Now, Graph database um, primarily has uh, ingredients, if you want to call them. One is node, which is a basic data entity, a label, which is, as it describes a label assigned to a node that means what it is. This node label is time, its location, and the relationship is a directed connection, as we see, going from location to impressions. This location has these many impressions, and the relationship has impressions. The same way impressions associated with period, impressions occurred at a time. And finally, the fourth one is property, which is a key value pair stored for a node. For location, the key value pair zip code, which could be 7701, city could be, and state could be North Carolina, as a key value pair for the property. So here, zip code is a property which has a value, state and city properties which have values as well. This is the actual relationships and properties that are in my database.
Suha, I'm so sorry to interrupt.
To the details.
Suha, I'm so sorry to interrupt.
The labels are time, impressions, location, and period. Location has served these many impressions. B at this time, time has month, day, and hours. So the number of impressions in a particular hour on a given day in a given month, or served at a period which could be sleep time, work time, or non non-work, non-sleep period. Then for data ingestion, I simply converted whichever tables I want to use into CSV files, added them into the import folder because I have been using Neo4j Desktop, and then started coding as I did not include the entire code base I used here because I did not want my slides to be filled with code. But as you can see, I created some constraints with saying that given location should be unique to avoid duplicates. And as you can see, next to constraints also in those particular nodes, and then created some shapes properties labels. For people who code in SQL, you are probably well aware the statements select is matched in Cypher, and insert is merged,
Suha,
and the rest
Suha,
is very
I'm
similar.
so sorry to interrupt.
You can see where statements here and create. It is very intuitive, very easy to follow. Now, Once I did that, I was able to access my graph database with so much ease. As you can see here, this shows the node network. I'm sorry, the node network and the impressions associated with it. If you can see on the left side here, all the impressions were served in. You can see the difference in the impressions served on this side versus this. That's because these impressions are aggregated um, in that month for that time, and whereas these um, lower values are associated with a particular hour. This is uh, 10th or October 11th at 2 a.m. And if we keep going, um, all I did there was simply click on that number, and now it gave me all the other nodes associated with that single number. And now that we zoom in on it, it's at on the 11th of month 10. And you can see that to say that, oops, let me go back here. We started from Newark and ended up
Suha,
at
can you hear me?
Bakersfield by just clicking through some numbers. One thing that stood out to me when I was looking at data this way is how easy it would be to show this to non-technical stakeholders and explain the data this way instead of walking
Suha?
them through any of the tables we create or the dashboards, which we can still create but painstakingly. Here, the data makes more sense and the anomalies can be looked at very, very clearly. If like if we go back to the beginning, we can clearly see that these are different from these impressions, and um, an interested person can go and click on 8 and see what is happening. Why are they impressions served at this hour, which is the least of all? And it's really easy to identify this. And once I got familiar with this set, I went ahead and because my research was facing when I was in PhD, I always think about in terms of faces. And there is this publicly available face recognition data set which is used to train a lot of open source face recognition models and used in face recognition competitions is CelebA, which has over 200,000 images with 10,000 identities. And this data set is collected in the wild, meaning these people, many of these people were not posing to be, they were not participants in a face recognition study. If they were posing, they were just posing for a picture. And along with other metadata, which includes which two images or which number of images belong to the same individual, they also have provide other attributes. Some of those are here in the sample images, like who was wearing eyeglasses, who has bangs, who has wavy hair, mustache, people smiling. From this, I took about 100 images, added those to a folder on my computer, and added the attributes from the CSV file as a graph database. And this is what I got out of that. I simply tried to match the node smiling, and these are the image names associated with the images from the CelebA set. That's how they provide them. So these many people are smiling. From there, if you select one image, you can see the attributes associated with that. And you can click on the attributes. I think that one says mouth slightly open. So these are the people who have their mouth slightly open. And another interesting thing is you can see which who among them have the same attributes and click on something else. And one interesting thing I noticed here is this person has wavy hair and straight hair. somehow. I When you notice something like this prompts you to go to this image seven dot JPEG or whatever that image and see what is happening. Is data mislabeled or this person curled only hair maybe or whatever the reason. This sometimes cannot be data like this might not surface when using flat CSVs or tables because you're just looking at a bunch of numbers. In this data set, particularly, the attributes that the process are labeled as 1, and the ones that are not are labeled as -1. Okay, I think I can get through this 5 minutes left. Okay, here are my key takeaways. I moved from rows to relationships. I was thinking in terms of only table joins and keys, but now I started thinking in terms of entities interacting with each other, not just what they are, and moving from features to context, where before this, especially in a data set, all the attributes were just independent, 40 independent columns for all the attributes, but now they are interacting traits as in which celebrity is smiling, has wavy hair, has brown hair, wears glasses. Any such information can be visualized much clearly. And moving from computation to exploration, which is not just thinking about what to join, but you can already see what's connected and think from there. Also from data points systems, if we go back to the hourly data versus monthly data, these two cannot exist as the same data, two separate tables. But by moving to the database, I was able to visualize as a complete system. I have used Neo4j, but they also provide a lot of other options to start exploring, start building. One of them is Neo4j Oracle, which is a fully managed system. Free tier looks like the free tier is available. There is Neo4j browser, and Cypher can be used as a Python library via Neo4j driver. And there is also Neo4j Bloom, which is a no-code visualization tool. If you get to use any of these, or just to say hi, this is where you can find me.